9.2 compound sentences. So if you think about compound sentences in language arts, it is where you have two sentences that come together with an and. So in this case, and there's sometimes other words, but that's typically the one that we think of. It's a conjunction is when you have two statements connected with the word and. So in math, we're looking at this. It's kind of like an intersection. It's where the two come together. X is greater than 5 and it's less than or equal to 12. So we're looking at, let's put this on a number line to see what it looks like. So first let's do X is greater than 5. So remember that it's an open circle because there's no equal sign. X is greater than 5 would be all the numbers on this side, 6, 7, 8, and keep going. Let's do X is less than or equal to 12. Closed circle because it has an equal sign. If it's less than or equal to 12, that means it's going to go all the way down here. Now, all the way down here. Keeps going. Where they are together, their intersection is what the answer is to this problem. So 1, 2, 3, 4, 5 was right here. So the X has to be bigger than 5, greater than 5, and less than or equal to 12. So we have our two circles. Remember that your 12 is closed because it was an equal sign. So if it's greater than 5 and less than or equal to 12, it's where the two would come together. So right here in between the two numbers. So let's go ahead and graph another one. X is greater than or equal to -2. Equal sign makes it closed. It's greater than -2. That would be 1, 0, all the numbers on this side. Then X is less than 1, open circle, no equal sign. If it's less than 1, it's coming this way. And in order for it to be a conjunction, they're really looking at what's between the two numbers. So if it's not going towards the middle, it's not a conjunction, not where the two come together. So if we're looking at, if we're looking at -3 is less than X and X is less than 4. So again, we're going to do our circle. They're both open circles. X is less than 4 would go this way. In order for it to be in conjunction, we got to be going that way. So -3 is smaller than the X. -3 is less than the X. So that means the X is bigger than 3. -3, pardon me. So if that bothers you that they're flipped, then flip it back. Just take it and flip it over. X and the open side is towards the X is greater than -3. So now we're looking this direction, which is what we were expecting. And their conjunction is what's in between them. So we can also write a conjunction like this. -3 is less than the X. And X is less than 6. So it's still, the and is in there, we just don't actually write it, we put it all together. So again, they're both without the equal sign, so they're both open. X is less than 6 goes this way. And again, -3 is less than X. So if -3 is less than X, that means -3 is smaller than X. So X has to be bigger. If that still gives you trouble, rewrite it. X and the open sides towards the X. X is greater than -3, which is kind of what we were looking for because we knew we were looking for a conjunction. If we don't know we're looking for a conjunction, that might look differently. All right, so now we're looking at this one. And again, we're going to be looking for the conjunction. X is less than or equal to 4, closed circle, less than 4. -2 is less than X. So again, -2 is smaller than X. So X would have to be this direction. Or rewrite it, X with the open side towards the X. -2, X is greater than -2. So that sometimes gets people some trouble, but rewrite it if it ends up doing that. All right, let's try this one. Now we have to solve it and graph it. So we're going to solve it just like we solved equations before. The only difference is we got to split this into two pieces now. This part is common to both. So -6 is less than or equal to 2x plus 4. And 2x plus 4 is less than 10. So we're going to split it off. We're going to do -6 is less than or equal to 2x plus 4. And we're going to do 2x plus 4 is less than 10. So now, draw your mirror. You're going to be solving an equation. Opposite operations has to be done on both sides. So we're going to do the addition and subtraction first. It's plus a 4. Opposite would be minus a 4. This gives us the 0 we were looking for. 4 minus 4 is 0. And we're left with 2x on this side, less than or equal to negative 6 and negative 4. We would add them together and get negative 10. Opposite, it's multiplication, so we divide. 2 divided by 2 is 1x. We don't need to write the 1. Negative 10 divided by 2 is negative 5. So we're looking at 1, 2, 3, 4, 5. Negative 5. X, and remember if it gives us trouble because we're reading it backwards, x is greater than or equal to negative 5. So we know it has to be a solid circle. If that's bothering you, flip it around. The open side is facing the x. It still needs to face the x. X is greater than that negative 5 or equal to it. So now let's try the other side. Again, mirror. You're going to subtract 4 from both sides. 4 minus 4 is 0. And you're looking at 2x is less than 10 minus 4, which is 6. Divide both sides by 2. Opposite operations. X is less than 3. So 1, 2, 3. There's my 3. Open circle. And x is less than 3. So they're going right here in between the two. All right, let's solve and graph another one. So again, we're going to separate it into two problems. Negative 18 is less than 3x minus 6, and 3x minus 6 is less than or equal to negative 3. Solving both of the problems. So opposite operations, adding and subtracting first. It's negative 6, so add 6 to both sides. That gives us the 0 we were hoping for. 3x, and we have the less than sign. Negative 18 plus 6 is negative 12. Divide both sides by that 3. X and the less than sign. So negative 4 is less than x. Okay, so again, we're going to draw our line. 0, 1, 2, 3, and 4. Open, because there's no equal sign. And x is greater than negative 4 if you're reading it from left or from right to left from the x over. X with the sign pointed towards it is greater than negative 4. So that means you're looking this direction. If it still bothers you, like I said, flip it around. X, then it's pointing away from the x, or the big open side is towards the x. So x is greater than negative 4. All right. So now we're looking here. We're going to add that 6 to both sides. Negative 6 and positive 6, when you're adding them together, gives you the 0 you were hoping for. So 3x, moving the sign down, less than or equal to positive 6 with a negative 3 would subtract. 6 is a larger number, so 6 is positive. My answer is positive. Opposite operations, both sides, we're going to divide by 3. 3 divided by 3 is 1. X is less than or equal to 3 divided by 3 is 1. So we have a closed circle at 1. It's less than or equal to 1, so that means it's in between those two numbers. Okay, solve and graph one more. So break it up. 5 is less than negative 2x plus 1. And negative 2x plus 1 is less than or equal to 3. Solving it. So draw your mirror. Opposite operations. Addition and subtraction first. Positive 1. Subtract 1 from both sides. 1 minus 1 is 0. 5 minus 1 is a positive 4. Bring down the sign. Negative 2x. Opposite operations has me dividing by negative 2. And what happens when we have an inequality and we divide by a negative number or multiply by a negative number? Hopefully you remembered that it means I have to switch my inequality. So 4 divided by negative 2 is negative 2. Negative 2 divided by negative 2 is 1, leaving x. But I have to switch my inequality from a less than to a greater than when I divide by a negative. Over here, opposite operations, subtract 1 from both sides, same steps, different problem. So negative 2x is less than or equal to 2. Dividing again by that negative 2, x is, and because we divided by the negative 2, we're switching the sign from a less than to a greater than. 2 divided by negative 2 is negative 1. So remember, we're looking for the conjunction. We're looking for where the two come together. So we've got negative 1 and negative 2. So I'm going to start with the easy one. X is greater than or equal to negative 1. We fill in the hole. It's a closed system. And it's greater than negative 1. That would be over in this direction. Again, reading from the x. X is less than, and if again it bothers you, flip it around. X is less than negative 2. Just make sure that if it's pointing at the x, then you have it pointing at the x. If it's open towards the x, you have it open towards the x. X is less than negative 2. So since we're looking for the conjunction where these two meet up, they never cross. So what we're looking at here, the actual answer to this problem, would be the empty set, because there isn't any numbers that fall into this bracket. No numbers are going to be less than negative 2 and greater than negative 1. It just won't happen. All right, so the last problem we did was actually called a disjunction. It's where two statements are connected by the word or. So when you're talking about the disjunction, it's a little bit more like a union. It's what all of one group and all of another group put together as a whole. So x is less than negative 3 or it's greater than negative 6, one or the other. So now let's look at how that would look. Both of them are open circles, no equal sign. X is less than negative 3. That would be this direction. So disjunctions go away from each other. X is greater than 6 is going to go in that direction. So nothing can be, both of them are going to be different. They're going to go away from each other, but we're putting them all together on one number line. Let's do another one. X is less than or equal to negative 1. Let's fill in the hole. X is greater than 4. So again, if x is greater than 4, we're looking at this direction. X is less than 1, we go in this direction. It's a disjunction. Okay, let's try one more like that with a disjunction. X is less than or equal to negative 6. Fill in the number because it's closed. X is greater than 2, open. So greater than 2 goes this direction. Less than 6 goes this direction. Remember that disjunction going apart. So we're going to solve and graph some. All right, so it's the same thing. We're going to solve both pieces, but these are actually set up for us. They're already two different problems. So negative 2x minus 6 is greater than 4, or x plus 5 is greater than 8. So again, we're going to be solving. We want the x by itself. It's a negative 6, so the opposite would be a positive 6. This is a 0, and we're left with negative 2x greater than 10. Now we're going to be doing division. We're dividing by a negative 2. What happens when I divide by a negative 2? Negative 2 divided by negative 2 gives me 1x, but because I divided by a negative, I've got to switch my inequality. 10 divided by negative 2 would be negative 5. So I get ready with my number line. 0, 1, 2, 3, 4, 5. So negative 5. It's less than negative 5. Fill in the circle, or sorry, open circle, not a closed, and open because there's no equals. Now let's do this side. One step solving. So it's plus 5. The opposite of a positive 5 is a negative 5. This is a 0. X is greater than 3. Why do I not switch the inequality there? I subtracted 5, and the only time you change the inequality is when you're multiplying or dividing by a negative number, not when you're adding or subtracting, only multiplication or division. So it moves out like that. Let's do another one. We'll do 2 more. Solve and graph. So again, we're going to rewrite the problems. Or x minus 3 is greater than 2. Now we're going to solve again. Opposite operations, it's plus 2. The opposite would be a minus 2. So do that on both sides. This gives us the 0. Negative 5x is greater than 25. Dividing by that negative 5. Remember, when you divide by a negative, it changes the inequality. 25 divided by negative 5 is negative 5. A positive divided by a negative is a negative. 25 divided by 5 is 5. One step over here. It's a minus 3. Opposite of minus 3 is a positive 3. This should give me 2 opposites equal 0. Negative 3 plus 3 makes 0. And I'm left with x is greater than 5. So again, we're going to draw our number line. 0, 1, 2, 3, 4, 5. Open circle. And it's greater than 5. So that means it's going this direction. And 1, 2, 3, 4, negative 5. Open circle because there's no equal. And x is less than a negative 5. Let's do one more like that. Negative 2x is greater than negative 14. 3x is greater than 21. So again, we're going to solve both parts. On the left side, we have multiplication, and the opposite of multiplication is division. So we're going to divide both sides by negative 2. Negative 2 divided by negative 2 is 1x. We just write 1x. Then the symbol for the greater than is now going to be a less than. So your inequality changes to a less than because you divided by a negative. Negative divided by a negative is a positive. 14 divided by 2 is 7. Okay, one step solving here. Both sides you're going to divide by a 3, opposite operations. X is greater than 7. So when we go to write this on the number line, here's my 0, 1, 2, 3, 4, 5, 6, 7. Open circle, and you'll notice both of them are 7. X is greater than 7. That means you're going in this direction. X is less than 7. Takes me in this direction. So the only number that is left out in this problem is 7. Every other number in the world is part of this graph.